We can also have logical vectors. Logical vectors basically store true, false, or NAs. They're usually generated by using conditions. So here I have a vector x, and I'm asking it, are any of the values in x greater than 13? So for each value of x, it will have a value of true or false, depending on um, whether that value was greater than or 13 or not. You can also use, so you can use less than sign, less than or equal to, greater than equal to, or even exact equality. Not equality, and then just like other Boolean things, you can actually have and or and things like that. Now, the important thing is when you want to reference a specific value in a vector, you do that by using this square bracket. So what this means is, in this variable v, the fourth position in that vector, that's what you're asking for. So what that provides you is the value of 8. Notice, for those of you who are used to other programming languages, the first value, it's not 0 based, it's 1. Okay, so the first value in this data is 1, not 0. Sorry. And then you can actually use this way, or this method of also reassigning specific values. So in this case, what I'm doing is I'm reassigning the value, the fourth position of v, to 10. And now if you look at the contents of v, you will see that it's this. Now, another thing you can use, and we'll use this later on again, is we can actually use logical vectors to reference the values you want to retrieve. So for example, if you have a vector v, and these are all your values, by doing v less than 5, what you're doing is you're asking for a logical vector to return. And you're storing this logical vector in z. And then what you're doing is you're asking, from my vector v, give me all the values that are true. And that's why you get back only the values that are less than 5. Okay? So let me do this quickly here so you can see what happens. So I'm going to replace so the fourth value, right? So if you return it, you see on the left that it showed 8. I'm going to change that value to be 10. And then if I want to look at it, I can just type v. And you'll see that the fourth value is now replaced with the 10. Now, I'm going to create a condition, a logical vector, that satisfies, or that asks the question whether v is less than 5. That's what I use, right? Yeah. Okay, so when I run this, you can actually get a glimpse of this value here. Okay, so z is true, true, false, true, true. And notice here, because there's a missing value, it's not going to evaluate this. It's just going to say NA and then false. So now I can say, for my values in V, give me back everything that's true. So here, it gives you all the values that are true. It gives you NA because it doesn't know what you want to do with the NA. Okay, but there are ways of avoiding NAs to be present. Okay. All right, so there's some other shortcuts of generating lots of sequential data. There is the 1:30 that generates numbers from 1 to 30. You can also use shortcuts like 1 to 15 means 1 all the way up to 15, but then do a mathematical operation on it, like multiplying it by 2, and then you get essentially all even numbers up to 30. Something that might be a little bit more useful is generating a sequence. So this says create a sequence starting at -5, go all the way to 5, and go every 0.2. So here's the command sequence. So by default, it does this. But there are a couple of things I want to point out here. One is that this command has options that it takes. And this is the order of options to some extent, right? If you know the order of the options, you don't need to specify what option this is satisfying. You can simply just give it. But if you don't know the order of the options, then it's best to assign it specifically and say length is equal to 51 from -5 by 0.2. Okay? So over here, I'm going to do question SEQ. So this will give me the help section for sequence generation. So when you run this, you get the help section, and here it tells you that sequence, the first option is from, the second one is to, then it's by, and then the length. So what this means is if there is a value attached to it, that means there are default values. So if you don't provide anything for from, it will just generate one. So this is saying from 1 to 1 by, it'll subtract the difference, divide by the number that's large, the length that you want. Okay? Right. So because of that, I can simply provide this. Sorry. I can provide this option. This option here. Notice one more thing. Sorry. Another thing I want you to notice is the arrow sign can be used to point to the other direction as well. So this is the main advantage of using this arrow, is that a lot of times you write something and you realize you forgot to assign it to a variable. You can just point it to the right and then give it the name of the variable. Okay, so you can use this arrow going to the right as well. So I ran this command, sequence -5 to 5 by 0.2, and now you can see S3 is basically going from -5 all the way to +5, going by every 0.2. And here, like I mentioned earlier, this 1 means that this is the first position in that vector. This -2.4 is the 14th position. This is 27th. This is the 40th. And so it gives you an idea of where these values are and how big they are. The other one, the other way of doing the same exact thing is telling it how many values you want and where you want to start from, and again how the sequence, like this. Okay. So both of them give you the same result. Just if you want to not, if you don't want to use these, if you want to be more specific about the options, it's always good to use this. But if you are so comfortable with these commands that you know which options come first and second, then you can use the shortcut method. The other one is repeat. You can repeat a certain every element in the vector at certain times, or you can tell it to repeat each element in that vector a certain number of times. So give it a shot and see what it looks like. So obviously you have your normal operators and functions, things you find in scientific calculators. But the important thing here is that you're going to be operating on the entire vector. And I think you got maybe a feel of it already, but you have some operation you want to operate on the entire vector. So this 2 times x is going to take all the numbers in x multiplied by 2 and create a new vector where all the values are there, and then you add vector by vector. So it's very, I guess, linear algebra friendly, if you want to think about it that way. And then plus 1 would add 1 to everything. Okay, so another thing that's worth mentioning are factors. This is a special type of vector because it allows you to group together values. Okay, so what you need to do is what I often do is I start with creating a character vector. So here in this case I'm creating a grouping of values, and I'm saying that the first value is in group A, second is in group B, third is in group A, fourth is in group C. So I'm grouping them based on some criteria, like maybe the condition or the experimenter or publication, whatever the grouping may be. And then I can make it into a factor by using this factor command. And now you'll notice that all of a sudden this vector x no longer has these double quotes. These are written as if they have no double quotes because they have a special meaning now. And another feature that these factors have is the levels. So the levels are the different groupings. So you have to be very careful here. What it's going to do is it's going to take words that are written identically and group them together. Okay, so if you have a misspell group A here with a capital G, it would think it's a completely different level. So always make sure that your these words are written carefully, and then you can actually make a grouping of them, and then doing some other operations like table will give you an idea of how many values in different groups are there. Why would you need this? Well, later on you'll see we can use this grouping to tell it which values are from which sample. So when we do t-tests, when we do ANOVA analysis, we can actually provide this type of grouping as a way of doing the